Hello, this is Les Walkling and welcome to this short presentation on selecting a source colour space for images intended to be printed. The intent in a contemporary ICC colour managed preservation workflow is to ensure the original image data is encoded in a large enough gamut with sufficient bit depth to preserve all of its values. Fit-for-purpose derivatives are then produced from this preservation asset, which includes scale, resolution, and gamut mappings. In practical terms, when a modern digital camera's binary data is encoded into a 16-bit per channel RGB profile with a large enough gamut, then all of its colorimetric data will be preserved. Also, when working in 16 bits per channel, even very low gamut images will occupy ample bit depth in large gamut color spaces without much risk, if any, of visible posterization being displayed or printed. Large RGB color spaces should also provide enough headroom to preserve even quite extreme tonal, saturation and hue edits. And a large gamut RGB color space will also ideally encompass any monitor and printed media's range of colors to ensure no captured, displayed or printed values are clipped or otherwise compromised in that RGB working space, at least for the majority of images. Consequently, applications like Adobe Lightroom Classic work within the colorimetry of Kodak's ProPhoto RGB archiving color space and a linear encoding. And as long as the RGB working space fulfills the above 16 bits per channel and sufficiently large gamut criteria, then common sense should imply an even larger color space will not confer any additional benefits. However, there are also competing rumours that printing from a larger rather than a smaller color space, such as printing from ProPhoto RGB rather than sRGB, does in some way improve the print's appearance. So here are the results of a simple experiment to determine first theoretically and then practically if there is in fact any advantage printing from a larger color space. Our first test image is 216 evenly spaced color samples encompassing the entire sRGB color gamut. Our second test image converts the sRGB image via a relative colorimetric intent into the ProPhoto RGB color gamut. This preserves all 216 color samples, only now housed within the larger ProPhoto RGB gamut. And in terms of real colors that can be seen, ProPhoto RGB is slightly more than twice the gamut volume of sRGB. For example, a Bradford transformation using D50 as the reference illuminant and CIE 2-degree standard observer functions results in sRGB encompassing 35% of the LAB gamut with 100% encoding efficiency, while ProPhoto RGB encompasses 78% of the LAB gamut when there is also 100% coding efficiency. The theoretical and actual printing tests are based on an Epson SureColor P900 printer with Canson Platine fibre rag paper, and where the test files contain both in-gamut and out-of-the-printer's gamut colours. The theoretical simulation perceptually converted both test images into the printer's gamut and resulted in no significant difference. That is, when the same colours are printed from either the smaller sRGB or larger ProPhoto RGB colour spaces, there is no significant difference predicted in their rendering. And because all 216 colour samples are within the smaller sRGB gamut, there is also no significant difference predicted with a relative colorimetric transformation to the printer's gamut. Subsequent actual printing of both test images confirms this prediction, where the print's visual appearance and measured values show no significant colorimetric differences, at least at the resolution of the 216 values in our test images. But these are also synthetic test images. Therefore, some actual landscape images whose values are preserved in the sRGB gamut were also printed. And again, there is no significant difference printing the same colours from the smaller or larger colour space. So how might we explain the rumours that printing from a larger colour space confers some pictorial advantage? One possible explanation might be when a very colourful test image's resolution is only 8 bits per channel, potentially resulting in visible posterization differences between the smaller and larger colour spaces. Another possible explanation might be an image with values out of the gamut of the smaller colour space, but accurately preserved in the larger colour space, and therefore all the image values are not the same in both working colour spaces, resulting in their printed appearance also not being identical. A further explanation might be when significantly out-of-gamut colours have been clipped by a relative colorimetric conversion into a smaller colour space, thereby obliterating the visual separation of those out-of-gamut colours, such as in this example where the jacket's hue and saturation textures are turned into a blob of undifferentiated colour. A perceptual conversion of the same colours preserved in a larger colour space would then result in those colours being rendered differently in the print. There is also the forced relative colorimetric transformation to our monitor profile, ensuring very saturated colours in a source colour space that is significantly larger than the monitor's gamut will to some extent be clipped in their screen appearance, but preserved in a print's perceptual conversion. And there may very well be additional considerations determining the source colour space to print from. But as long as we are working in 16-bit resolution, there appears to be no disadvantage in coding our processed RGB files into a larger colour space when they are destined for printing. Hopefully this has been informative and helpful, and we wish you all the best with your printmaking adventures.